Welcome, and the question we're going to be working next is a question from May 2019, paper 8, paper 2, questions A, B, C. This is September 2019, and I'm going to be working this question step by step with special focus on part B. So, part A, you were told that 2.06 grams of organic liquid H occupies 620.34 centimeters cubed when vaporized at a temperature of 90 degrees Celsius and a pressure of 1 atmosphere. Calculate the RMM of compound H. So this question you require to use PV equals nRT. And as I always say, start by writing what you know. It's 1 atmosphere's volume is 620.34 centimeters cubed. Number of moles, matafouche. R equals 8.314. T is 90 degrees Celsius. But you must note that these are not the SI units. So this will have to be 101.250 pascals. Volume will have to turn to 620.34 times 10 to the minus 6 meters cubed. Number of moles, we don't know. Temperature, you have to add 273 Kelvin, which is equal to 363 Kelvin. And now you can put them in your equation, where 250 times 620.34 times 10 to the minus 6 divided by 8.314 times 363 equals n, and n is equal, give me a second to work it out, and we will be able to move on. So 101.250 times 620.343 times 10 to the power of minus 6, all divided by 363 divided by 8.314, and that would be equal to 0.02081 moles. So 0.02081 moles. Now, the question is that first and foremost, you need to find the mass of compound K. So if 0.02081 moles is equal to 2.06 grams, okay, 1 mole is equal to how much? And that we can easily find out by doing the 2.068 grams division by the number that we've got in here, and that would be equal to 98.98 or 99 grams. Okay, so it is 99 grams per mole. So once we found that the RMM is equal to 99 grams, we can move on to question B. Question B was this. The mass spectrum of compound H has the following main characteristics. A parent ion having 3 distinct peaks with a ratio of 9 to 6 to 1, and 2 additional fragments detected at MB of 49 and 51, with these 2 peaks present at a ratio of 3:1. So there are 2 ratios. 9:6:1 and 3:1. And this should immediately result in chlorine being present. And apart from this, the ratio here relates to 2 chlorines being present. Okay? So each peak, peaks 49 and 51, would result into being CH2Cl. Okay? So CH2Cl is either 49 or 51, because that could be Cl35 or Cl37. So now, using this information, we know that if the peak is exactly 49 or 51, and there are no other peaks, then the parent compound has to be carbon, carbon, chlorine, chlorine, hydrogens, hydrogens, hydrogen, and hydrogen. And this would have an RMM of 99 grams. Remember, the RMM of chlorine is 35.5. So let's actually rephrase and re-explain how we go to this position. So we have the peak 3:1, which means that chlorine must be present. The peak 9:6:1 shows us that 2 chlorines are present. Okay? If you don't get the hint because of the ratio of 9:6:1, maybe you've never actually seen this before, then realize that the molecule was divided into 2, and therefore it must be that the 2 peaks are the same. So if one peak is CH2Cl, the other half must also contain CH2Cl. And that gives us the structure of dichloro or 1,2-dichloroethane.